Questions 11 through 20 on the 2019 Grade 12 AMC 12A. For some positive integer k, the repeating base k representation of the base 10 fraction 7 over 51 is 0.23 repeat to the base k, which equals 0.232323 ... to the base k. What is k? Well, I hope you're familiar with base k representations. I'll give you a very brief example. Let's say I have the number 173 to the base 11, and I said, what is this number? Well, it would be 1 times 11 to the power of 2 plus 7 times 11 to the power of 1 plus 3 times 11 to the power of 0, and whatever number that works out to. But I just wanted to illustrate how that's done. So, keeping in mind now, we have a different scenario here. We've got k's. So I'll just let x equal to this 0.23 repeat to the base k. Now, I want to expand this the way I did over here. But it's a little bit different because I've got the numbers after the decimal point. So it would be 2 times k to the negative 1 plus 3 times k to the negative 2. So that means this is 2 over k plus 3 over k squared. And that is x. Well, let's see if that helps me. I don't know. Now let's turn our attention to the expansion of this 0.23 repeat, 0.23 repeat to the base k. Now, if it was base 10, we would multiply by 100 to bring these two before the decimal point. But we don't have base 10, we have base k. So we can't multiply by 10 squared, we have to multiply by k squared. So when you multiply by k squared, that's what allows you to bring 3 before the decimal point, like that. Okay, now what I'm going to do is just subtract those two. So I've got k squared x minus x. And then this would be 23.23 minus 0.23. Repeat, and these are base k. So if I factor out an x here, I get k squared minus 1. And then this wipes out all of the decimal from both of them. So it just becomes 23 to the base k. Well, 23 to the base k is 2 times k to the power of 1 plus 3 times k to the power of 0. And this is the same. And this just becomes 2k plus 3. And then I'll bring that k squared minus 1 over, and that's x. And x, we know, is equal to this right here. But the question tells me that in base 10 it's equal to 7 over 51. So this, in base k, is this, but in base 10 is 7 over 51. So I can put that 7 over 51 here, and that will allow me to solve for k. So there we go. So cross multiply and get 7k squared minus 1 is equal to 102k plus 153. Put everything on one side and get 7k squared. This should be 7. Minus 102k minus 160 is equal to 0. And I think this should factor 7k, k, 10 and 16 plus negative. So that means k is either 16 or negative 10 over 7. And obviously the answer would be 16. So number 18, that is D. Positive real numbers, x not equal to 1, y not equal to 1, satisfy log of x to the base 2 is equal to log of 16 to the base y. And x times y is equal to 64. What is the log of x over y to the base 2 all squared? Let's make things a little simpler. Let a be log of x to the base 2. And let b be log of y to the base 2. So with those substitutions, I can write the following, that the log of 16 to the base y, which is this guy right here, is the log of 2 to the power of 4 to the base y. Bring the 4 out front, and you get 2 to the y. Log of 2 to the base y. Now you have a log rule that says you can interchange those, but you'd have to then put it in the denominator, so it would be log of y to the base 2, like that. So since the log of y to the base 2 I have called b, this just becomes 4 over b. Okay, so now let's talk about log of x to the base 2 is equal to the log of 16 to the base y. That equation that they've given me up here. Well, this part I have called a, and this part right here I just figured out was 4 over b. So that means a times b is equal to 4. Okay, so far so good. Now I want to take into consideration that part right there, that x times y is equal to 64. Well, x is what? From here, x is 2 to the power of a, and y from here is 2 to the power of b, and that's 64. So that means 2 to the power of a plus b is equal to 64, which is 2 to the power of 6, and therefore a plus b is equal to 6. Okay, so I've got a times b is equal to 4, a plus b is equal to 6. So now I'm ready to tackle this guy, which is what they want. And that guy is log of x over y to the base 2 all squared. Well, using log rules, that's going to be the log of x to the base 2 minus the log of y to the base 2 all squared. The log of x to the base 2 we had originally called a, and the log of y to the base 2 we had called b. So this becomes just a minus b squared. And if you expand this, you get a squared minus 2ab plus b squared. Rearrange it, a squared plus b squared minus 2ab. And then if I have a plus b all squared, then that, I'll just put it on the side here, that's a squared plus 2ab plus b squared. But I just have this, so if I put this in here, I've got to subtract a 2ab. And then don't forget that 2 minus 2ab. So this really just becomes a plus b squared minus 4ab. So as you can see, we had to do a little bit of manipulation. Okay, well, a plus b we know is 6, so that's 6 squared, minus 4 times ab, which is 4. So that's 36 minus 16, which is 20. And there you go. So number 12, the answer is B. How many ways are there to paint each of the integers 2, 3, until 9, either red, green, or blue, so that each number has a different color from each of its proper divisors? We have 2, 3, 4, 5, 6, 7, 8, and 9. Well, this has no proper divisors. This is also no proper divisors. Those are both prime. This has a proper divisor of 2, none here, 2 and 3, none, 2, 3. These are the proper divisors. Okay, so let's talk about this. For the first one, 2, we can put any of the 3 colors. For the next one, 3, we can put the same color as I did for 2. And if I do, there's only one choice. Whatever color I put for 2, I put for 3. Or I can put a different color for 3. And if I do, I've got 2 choices. Whatever color I put for 2, I choose one of the other 2 choices, since there's 3 choices in total. For 4, I cannot put what the 2 was colored. I can put another color. So since there's 3 and 1 is already taken, I have two choices. Here I have 3 since that's just prime, so it has no proper divisors, so I don't have to worry about any proper divisors. 6 has 2, and there's 2 proper divisors. So if the color of 2 and 3 is the same, then I've got 2 choices for 6. If the colors of 2 and 3 were different, then I've got only 1 choice for 6. 3 choices for 7. 8, I cannot put the color for 4 or the color for 2. Those are proper divisors of 8, actually. So that means that leaves me with only 1 choice. And 9, I cannot put the color for 3, so that leaves me with just 2 choices. Okay, so now let's combine these. The first is if the color was the same for 2 and 3. So it's these guys right here. All those. So that gives me 3 times 1 times 2 times 3 times 2 times 3 times 1 times 2. And that looks like 6, 6, and 6, so 216. The next scenario is if they were different. So it's these ones. If they were different meaning the colors for 2 and 3. So this one and this one, if they were different colors, it would be 3 times 2 times 2 times 3 times 1 times 3 times 1 times 2. And that is 3, it looks like it's the same. Yeah, 216. So I guess I have to add these, and when I do, I get 432. So number 13, the answer is E. For a certain complex polynomial C, for a certain complex number C, the polynomial Px, which is equal to x squared minus 2x plus 2 times x squared minus 6x plus 4 times x squared minus 4x plus 8, has exactly 4 distinct roots. What is the magnitude of C? All right, well, we have to first figure out what are these roots, and I think those will help me. So let's look at the first one, x squared minus 2x plus 2. If that equals 0, using a quadratic, we get x is equal to 2 plus or minus the square root of 2 squared minus 4 times 2 all over 2. And that is 2 plus or minus 4 minus 8, so minus 4 over 2. So that is obviously 2 plus or minus 2i over 2. And that is 1 plus or minus I. In a very similar way, let's look at that one. X squared minus 4x plus 8. And let that equal to 0. So x is going to be 4 plus or minus 4 squared minus 4 times 8 all over 2. So that gives me 4 plus or minus 16 minus 32, so minus 16 under the square root. And that gives me 4 plus or minus 4i over 2. So x is 2 plus or minus 2i. Okay, so obviously we have 2 here and 2 here, so we got 4 roots in total, which is exactly what they wanted. Now, I've got to figure out how to make that. Since 2 roots come from there and 2 roots come from there, I can't have any more distinct roots from there. The roots of this have to be either from there or from there. Okay, but I've got to do it in a way so that it looks like that. And I think I can. Right off to the side here, I'm really just interested in that 4. How do I get that 4 at the end? And I think if I use 1 plus I, which I got from here, that's one of those roots, and if I use 2 minus 2i, which is one of these roots, I think I can get a 4. This would be 2 minus 2i plus 2i minus 2i squared. So these guys cancel, so this becomes I squared is negative 1, so that's 2. Yeah, this becomes 2 plus 2, which is indeed 4. Okay, so a little bit of experimentation there to figure out which roots we have to use to make it look like that. Okay, so that means x squared minus cx plus 4 is obtained with those two roots. So x minus 1 plus I times x minus 2 minus 2i. So there we go. Okay, this will allow me to solve for c. So this becomes x squared, I'm expanding now, minus 2i x minus 1 plus I x, and then as we had previously figured out, 4. So if we expand this whole thing and collect like terms, it would be minus 2 plus 2i minus 1 minus I, and that's the coefficient in front of x, and then a big 4 at the end. So that coefficient is, let's see here, minus 3 plus I. Okay, so that means this minus c is equal to this coefficient, minus 3 plus I. So that means c is equal to 3 minus I. So to take the magnitude of c, you just take the square. If you remember a plus bi, if I were to take the magnitude, it would be a squared plus b squared square root. So in this case, I have 3 minus 1i. Stick that 1 in there if you really want to. So that would be 3 squared plus negative 1 squared under the square root, and that is 9 plus 1, so root 10. So root 10 is the answer to number 14, which is E. Positive real numbers a and b have the property that the log of a under the square root plus the square root of log b plus log square root of a plus log square root of b is equal to 100, where all four terms on the left are positive integers, where log denotes the base 10 logarithm. What is a times b? Well, again, let's make some substitutions here. I will let the log of a equal x and the log of b equal y. So substituting into that, we get root x plus the root of y plus, well, this one is a little bit different. I'll just write it up here. The log of root a is the same as the log of a to the 1/2. And you bring the half out front, so it becomes the log of a. So that is going to be the log of a half x, so that becomes x over 2. And in a very similar way, the next one becomes y over 2. And that equals 100. Now, when you get to this part of the question, I thought about this a long time, and I said, well, where do I go from here? Do I use a quadratic? Do I factor? And then I realized that this question is really just about experimentation. It hasn't, as far as I know, there's no actual scientific way, where you have to, you sometimes you use a quadratic or sometimes you use a factoring method. This is just trial and error. So basically, I've got to figure out two numbers that when I sub them into here, namely for x and y, I get an answer of 100. That's really all it is. So you sit around, you fiddle around with these numbers now. Okay, well, obviously, the numbers have to be perfect squares, right? Because eventually you're going to get an integer for an answer. Okay. Now, of course, I've already done this, so I'm going to be able to do it on my first attempt. So, but with you guys, you might have to take a little bit of time. But always use the answer choices. The answer choices are definitely going to help you to give you an idea of what x and y could be. So I started, let's say, okay, let's see if x is 100, what happens? Then this becomes 10. This becomes 50. Okay, I've got 10 plus 50, I've got 60. I got to get another 40. How do I get another 40? And after some thinking, I said, well, what if y is 64? That would make that 8. And it would make this 32. And there you go. That would all add up to 100. And that's really how you do it. Unless there's some other way that I don't know. So now what do they want? They want a times b, right? Okay, well, this gives me that 10 to the power of x is a. And this gives me that 10 to the power of y is b. So a times b is 10 to the power of x times 10 to the power of y, which is 10 to the power of x plus y. And it looks like x plus y would be 100 plus 64, which is 10 to the power of 164 for AB. There you go. So number 15, the answer is D. The numbers 1, 2, ... until 9 are randomly placed into 9 squares of a 3 by 3 grid. Each square gets one number, and each of the numbers is used once. What is the probability that the sum of the numbers in each row and each column is odd? Right, well, 3 numbers are going to be odd if what? What is the scenario? I have to first figure that out, because I'm going to treat this, forget about the numbers. I'm just going to look at it as odd and even. That's the only thing I'm going to look at. Well, 3 numbers can have these types of scenarios. Even, odd, even, odd, or odd, odd. The only time that the sum is odd is here and here. These will give even. So I'm really just interested in this scenario and this scenario to fill my square. So what I'm going to do is just going to draw one square and sort of show you how that would work, and then we'll try to figure out how many other ways are there of doing that. So here we go. I want odd, and even, odd. Well, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. These ones are even, so there's 4 even, and therefore the other 1, 2, 3, 4, 5 are odd. So I've got to put 4 even and 5 odd in this grid. Okay, one way of doing that is doing odd, odd, and then even. That's one way. Another way would be odd, and then just kind of move the, I guess, 3 in a row column to the right a little bit. Another way is to do it like this, and then you get the evens there. So that takes care of all the ones where the odd was the top row. How about we make it the middle row, and then we sort of do the same kind of thing. There's 1, and then let's move that. There's 2, and then we're doing it for the middle, right? So move it there, and that's another one. And then the last one would be when the odd is the bottom row. So that's this kind of scenario. And then again, we can make very quickly the different scenarios. Here's one more, and last one, odd. There we go. So these, I got 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So my probability is 9 over something. Now what's my something? Well, the denominator in a probability question is always the total number of ways. The total number of ways, without regard to any rules, is from the 9 numbers, you want to choose 5 for the odd, and from the remaining 4, even, you choose all of them. So this is basically the answer. So 9 choose 5 is 120. It's basically 9 factorial over 4 factorial over 5 factorial, which is 126. And there you go. That's the answer. And of course, they're going to lower it to lowest terms, which would be 1 over 14. So number 20, the answer is B. Let Sk denote the sum of the kth powers of the roots of the polynomial x to the power 3 minus 5x squared plus 8x minus 13. In particular, S0 is 3, S1 is 5, S2 is 9. Let A, B, and C be real numbers such that Sk plus 1 is equal to A, Sk plus B, Sk minus 1 plus C, Sk minus 2 for k equals 2, 3, ... What is A plus B plus C? Well, you take this equation, and let's experiment with this a little bit, the one that's given in the question. Let's say one of the roots is r. Let's say call it r1. There's going to be, what, 3 roots, right? Because it's a third degree polynomial. So our roots are going to be r1, r2, r3. So let's substitute in r1. It doesn't really give much difference. Okay, now at this point, this is where the trick comes in. We have to multiply through by r to the power of k minus 2. And when you do, it will start to look very similar to that pattern. Okay, when I multiply that, I get the following. It would be r1 to the k plus 1 minus 5 r1 to the k plus 8 r1 to the k minus 1, and then minus 13 times r1 k minus 2. And because it was a root, we can set it equal to 0, because when you put in the root, it equals 0. So this all equals 0. Rearranging this a little bit, putting the rk plus 1 on one side and all these guys on the other side, we get the following. Okay, so this is a pretty decent equation. Let's do the exact same for r2 and r3. Now something interesting happens, and it basically is entirely from the question stem. Let's read the question stem again. Let sk denote the sum of the kth powers of the roots of the polynomial. So that means that if you add these guys, you basically will get the following. This would be sk plus 1, right? It's the sum of the kth powers of the roots of the polynomial. In this case, it's the k plus 1 power. And then similarly here, this would be 5, and then you add up these guys, and that would be sk. Here, minus 8. You're adding up these 3, that's sk minus 1. And then, of course, those 3 with the 13 out front is sk minus 2. So now we look at this, and it looks very similar to this. And that is, I'll just write it right below, sk plus 1, ask plus bsk minus 1 plus csk minus 2. So in comparison, a is 5, b is negative 8, and c is 13. So they wanted a plus b plus c, so that's going to be 5 minus 8 plus 13, and that is 10. So number 17, the answer is D. A sphere with center O has radius 6. A triangle with sides of length 15, 15, and 24 is situated in space so that each of its sides is tangent to the sphere. What is the distance between O and the plane determined by the triangle? So here's a diagram which I think helps greatly to understand the question. And they have told us that AB is 24, and it's an isosceles triangle, so AC is equal to BC, and those are equal to 15. So we can draw a line down the middle of that isosceles triangle, and because it's isosceles, that line will cut the other side in half. So that means AD and DB will now be half of AB, so 12 and 12 like that. Okay, so now at this point we can figure out the value of CD pretty easily using Pythagoras. CD squared plus DB squared, which is 12 squared, is equal to CB squared, which is 15 squared. So that means CD is going to be equal to 9. Now we can calculate the area of that triangle ABC. ABC has an area 1/2 base times height. The base is 24. The height we just figured out was 9, and that is 108. Now we have a very special formula, and this formula states that if you have any kind of circle like this that is inscribed inside a triangle like this, it's tangent to it inside, the area of that triangle is equivalent to the radius of this circle that's inscribed inside times S, where S is the semi-perimeter. And this is a very helpful formula for this question. The area we just figured out was 108. The radius, that is what we will find out. And the semi-perimeter, well, that's easy to figure out. The perimeter is 15 plus 15 plus 24. And then the semi-perimeter, you just divide by 2. So that makes this 108 is equal to R times 30 plus 24 is 54 divided by 2 is 27. So R is equal to 108 over 27. Therefore, R is equal to 4. So now going back to the diagram, we want to figure out this distance right there. And I'll just call that D. We just figured out that, which is the radius of the circle, is 4. And then from O to that point is the radius of the sphere, which they had told me in the question was 6. So now it just boils down to a simple Pythagorean relationship between 4, D, and 6. And when you do this math, you get D is equal to root 20, or 2 root 5. So number 21, the answer is D. In triangle ABC with integer side lengths, cos of A is 11 over 16, cos of B is 7 over 8, and cos of C is negative 1 over 4. What is the least possible perimeter for ABC? Well, let's draw some right triangles. Let's draw 1, 2, and 3. It doesn't really matter what they look like. We just have to illustrate this. Okay, so for the first one, if this is angle A, then if the cos of A is 11 over 16, then this is 11, and this is 16. And using Pythagoras, you can get this side. It would be 16 squared minus 11 squared square root, and that is root 135. So root 135 goes here. And in a very similar way, another right triangle, cos of B is 7 over 8. So this is 7, this is 8. And we can find the other side. It would be 8 squared minus 7 squared square root. And that is root 15. And then again, this time a little bit tricky because we got a negative there. But there's an identity that the cos of theta is equal to the cos of negative theta. And even if you didn't know that, you can deduce that from the graph of cosine. So the cos of C is the same as, and it doesn't really matter because you're going to square it anyways. So even if this was negative 1, I know that doesn't make any sense. But even if you did that, let's say it was on the other side of the x-axis, to get this side, it would just be 4 squared minus negative 1 squared square root, which is root 15. Okay, doing that allows us to get the sine values. So the sine of A, therefore, would be 135 square root over 16. The sine of B would be root 15 over 8. And the sine of C would be root 15 over 4. All right, so now we're going to use the sine law. The sine law, which I'm sure you know, states that if the sine of A over A, which is the small a denotes the side length, if you have that ratio, it's equal to the sine of B over B, which is equal to the sine of C over C. So let's put that in there. We've got 1 35 root over 16 over A, then root 15 over 8 over B, and root 15 over 4 over C. Now let's multiply through by 16 over root 15. And when I do, that's going to give me 135 root is 3 root 15. So it's going to be 3 over A. And then this one will give me 2 over B. And this one gives me 4 over C. So this equation, in terms of the minimum possible values that would satisfy it, if A is 3, B is 2, and if C is 4. And that would make a triangle with those three sides. And the perimeter, therefore, would be 3 plus 2 plus 4, which is 9. And this is the minimum possible way of doing this. So number 19, the answer is A. Real numbers between 0 and 1 inclusive are chosen in the following manner. A fair coin is flipped. If it lands heads, then it is flipped again, and the chosen number is 0 if the second flip is heads, and 1 if the second flip is tails. On the other hand, if the first coin flip is tails, then the number is chosen uniformly at random from the closed interval 0, 1. Two random numbers x and y are chosen independently in this manner. What is the probability that the absolute value of x minus y is greater than 1/2? If there's a heads, we have to flip again. And when we flip a second time, if it's heads, we get a 0. If it's tails, we get a 1. The other scenario is if you flip the first time, you get a tail. And in that case, you're going to choose some number at random from 0 and 1 inclusive. So now let's put in the probabilities. The probability of getting a head is 1/2, and the probability of getting another head is 1/2. So the probability of getting 2 heads in a row is 1/2 times 1/2, which is 1/4. Probability of getting a head is 1/2. Probability of getting a tail is 1/2. So the probability of getting a head and then a tail is 1/2 times 1/2, which is 1/4. And now these guys, I'm going to break these up into 2 because that's what's going to help us in the question. We can either choose something that's between 0 and 0.5, or we can choose something that's between 0.5 and 1. And each of these has a probability of 1/2 times 1/2, which is 1/4. Why? Well, the probability of getting a tails in that first flip is 1/2, and then the probability of getting this half of the range is 1/2, so that's why you have to multiply 1/2 by 1/2. And very similarly, 1/2 to get a tail and 1/2 to get that half of the range. So this is also going to be 1/2 times 1/2, and that's 1/4. So now what we do is we make a table, and the table will help us figure out this little inequality that x minus y absolute value is greater than 1/2 or not. So let's now fill in the table. We've got x, y, absolute value of x minus y, and then we have the probability that it is going to be greater than 1/2. So we can fill this out 0, 0, 0, 0. We can have either 1, 1, 1, 1, or we can have these ranges 0 to 0.5, or we can have 0.5 to 1, like that. So let's fill all of these out. So now we got to look at this column right here and figure out what is the absolute value of x minus y, and whether it is going to be our requirement that it's greater than 1/2 or not. So there we go. I just filled out all of the possible values of the absolute value of x minus y for all of those. And some of those are 0, some of those are fixed as 1, some of those are less than 1/2, and some are greater than 1/2. But there's 2 that I put a little asterisk because those are greater than a half the time, and less than a half the time. That's why I put a little asterisk there. Now let's figure out the probability, but the only ones we're really interested in are the ones that are greater than a half in this column. So let's just circle those. This one, greater than a half, remember. So this one, that, and then here, and here. Okay, so the probability that, now we have to fill out this column here. The probability is calculated as follows. What is the probability of choosing that x, and what was the probability of choosing that y? The probability of getting that 0 is a quarter, and the probability of getting this 1 is a quarter. So you have to multiply a quarter by a quarter, and that's 1 over 16. And the same thing here. What was the probability of getting a 0? It was a quarter. What was the probability of getting that range, 0.5 to 1? Well, that's here. It was a quarter. So again, a quarter times a quarter is 16. And as you can probably deduce, it's the same way to get all the other probabilities. But this question is a little tricky because of these guys, this asterisk and that asterisk. In those two scenarios, it's greater than a half only half the time for this range. The other half, it'll be less than a half. So that's why you have to multiply this 1 over 16 times a half. And you have to multiply this 1 over 16 by a half. So now let's add them all up. We have 1, 2, 3, 4, 5, and 6 times 1 over 16. And then we have this guy, which is 1 over 32. And then this one, which is also 1 over 32. So this gives me 6 over 16. This is 2 over 32, which is 1 over 16. And that is 7 over 16. And that is the answer to number 22. 7 over 16, which would be B.